Okay, so they're asking you to graph this thing, and we're going to go back to that old school thing about remember what transforming the graphs do, because that is a skill you'll definitely need, right? Do you remember this? Y equals a times x minus h squared plus k. Okay, you don't remember. Well, it's good that we covered this then. All right. What does a do? You guys recall that? It's what I call the gummy bear factor. There we go. Bradley says it's the stretchy pants.
Okay, yeah.
It stretches, right? It either stretches or compresses. And this is important to know because this is applicable to all kinds of functions, not just parabolas, but cubic functions and quartic functions and exponential functions and logarithmic functions, and even functions you haven't necessarily seen before, like absolute value functions and all of those kinds of things. We're going to keep on coming back to this lesson. So if a is a big number, then it stretches vertically. If a is a fraction, then it compresses. And if a is a negative number, then what? It goes down.
Yeah.
Right? It was opening up, and then it goes down. And Diamond said it's flipped, which could be slightly derogatory, but I'm not even going to go there. I'm just joking. Okay, what does H do? Actually, you know what? Let's go with the easier one. What does K do? Bradley says it's the y-intercept. I disagree. It's not the y-intercept. It was the y-intercept when we were talking about exponentials, and I always would come back to Sophia and say, well, technically you're right, and that kind of stuff. No, it's not the y-intercept. What it does is it pushes your function up or down. That's all it does.
Oh, but it's the number on the line.
It takes the whole thing and moves it up.
Okay.
Or it takes the whole thing and moves it down. And in this case, it's not the y-intercept. Or at least not guaranteed to be the y-intercept. And I'll show you why. So if k is 4, let's graph the function they gave us. They gave us h of t is equal to negative 4.9 t squared, what is it, plus, I can't see, plus 4? Okay, so immediately, all that has is an a and a k. It doesn't have an h. If it had an h, it would look something like this. Negative 4.9 t minus 7 squared plus 4. But it doesn't. It doesn't have that h thing, so I'm not worried about moving it right and left. Okay? Yeah, and remember the thing inside the parentheses moves it right and left, but the thing outside moves it up and down. You guys recall this, right? Anyway, let's graph this. We graph this, and we know we're going to have a parabola that it goes upside down. It's vertically stretched. So here's my regular parabola, and then I'm going to make it upside down. I'm going to vertically stretch it, so I'm going to make it skinnier. You guys agree? And then I'm going to take the whole dang thing and I'm going to push him up 4 units. 1, 2, 3, 4. We cool? I know it's an ugly graph, it's just because I had to erase it a bunch of times. And Bradley is saying to himself, because me and Bradley, we have a funny rapport. Bradley's saying, what the heck, Mr. Dalday, that is the y-intercept. 4 is the y-intercept. And I agree. I agree with you. But, what if I did move this thing right and left? What if I moved it to the right 2 units? Writing that down, that would be negative 4.9 times t minus 4 squared. Oh, no, I'm sorry. 2 units would just be 2 over here, plus 4. That would make a graph that goes over here. And then it no longer is the y-intercept. That number is not just the straight up y-intercept.
Mhm.
You're right, Bradley. It's the y-coordinate of the vertex. I agree with you. And if your vertex happens to be on the x equals 0, then yes, in that very specific case, your y-intercept is the same as the y-coordinate of the vertex. But that's too many rules for me to remember. You know what I mean? Like, oh, it is the y-intercept. If h is 0, then it's the y-intercept. No, just think of it as that's the y-coordinate of your vertex. That is how much you're pushing or pulling your graph down by. If you want to know about the y-intercept, I'll tell you the trick. It's actually not even a trick. It makes complete sense. To find the y-intercept, you set the x value equal to 0. To find the x-intercept, you should set
Y to 0.
the y value equal to 0. It's pretty straightforward. Okay? That's your rule for y-intercept. In the very specific case when we're talking about exponentials, actually, Sophia was right. That extra value always ends up being the y-intercept. But, that's not always the case. So I don't want to accept it as a general rule. And even in this particular case right here, Bradley, you're right. That is the y-intercept, the 4 y-intercept. But that's only because I didn't have an h value that moves my parabola right and left. Okay?
Are we graphing this in this question?
Yes, I believe you're graphing this. So, let's see. I think the best thing to do is, I gave you a ballpark idea of what the graph would look like, right?
Yeah.
But, I'm realizing that that's not necessarily sufficient to answer this question because you don't know exactly how the graph looks like. I told you, it stretches it, you know what I mean? But you don't know how exactly it stretches it by.
Is it?
Yeah, what I would do is I would plug in points. You know what I mean?
Yeah.
I would say, well, if x equals 0 in my h of t equals negative 4.9 t squared plus 4. Actually, I'm sorry. If t is equal to 0, then h of t is equal to 4. Okay, that's a good point, all right? Then I would say, well, if t equals 1, then h of t would equal negative 0.9. So if I plug 1 over here, I've got negative 4.9 times 1 plus 4. It's just negative 0.9. Cool? And I would make my parabola make sure that it crosses through those 2 points. That's how officially I would graph it.
Okay.
Got it?
Yeah.
I kind of want to take a look at the next ones because I know that this technique of graphing things. Okay, I'm going to skip over to, I'm not going to stop the recording. I'm going to skip over to question 11. And it's asking you to graph this. Q of x is equal to 2 log x plus 4 plus 5. Kayla,
Yeah.
you're looking at this and freaking out and thinking to yourself, I'm going to read your mind right now.
I just can't find the question.
Yeah,
Okay.
when I didn't staple it, it's all over the place. All right. This is page 11.
Page 11 or question 20?
Oh, page
okay.
11, question 5. All right. Kayla,
Yes.
actually, you know what? Don't. Yeah, okay, fine.
Okay, now.
You're looking at this and freaking out and saying, I've never learned this before.
Oh, yeah.
But don't worry, because Diamond and Bradley are also both looking at this and saying, what the heck, Mr. Balde? You've never taught this to us before. In my excuse, in my defense, I was going to say, well, actually, that was exactly the next thing I was going to teach you, to be honest with you. Honestly, I taught you about exponential functions. Logarithmic functions are related to exponential functions. I never taught it to you. And so you guys are thinking, what the heck? How am I going to be able to solve this problem on the test if you've never taught it to us? Okay. Here's my question. Yeah, Bradley says, I'm not. I'm just going to skip it. I'm going to fail the test. All right, Bradley, calm down. You know what? Calm down. Maybe I should always wear a shirt. Bradley, calm down. Okay. An exponential function looks like what? Do you guys know how that looks? The graph.
Is that the like?
Kind of looks like this.
Yeah.
Yeah? Yeah? Are we good? Okay. Look at your options. It says graph this thing. I'm on page 11. It says graph this thing. And look at A. Is that a graph of a logarithmic function or an exponential function?
Exponential.
That's exponential. It's not A. Cool, so we can cross that one out at least. Got it? By the way, for those of you who don't have the PDF, A looks like this. And to me, that looks like an exponential function that is pushed up and pushed to the left. Because the regular exponential function looks like that. Do you see how powerful this technique of learning how graphs transform can apply to knowing things that you don't even know?
Yeah.
I think it's awesome. Okay. So, let's look at graph B. Graph B has a graph that looks like this. Is that the right answer? No.
Because it says no.
Well, because on the paper you gave us, which has all the answers, says no. No, but look. What kind of graph would you say this is?
Oh, is it exponential?
It's another exponential. Right?
Yeah.
So I would rule that one out too. Because it's asking you to graph a logarithmic, and you don't even know what a logarithmic graph looks like, but you know that it doesn't look like an exponential.
Okay.
Right? All right. So the other two options look like this. The other two look like this. Something like that. All right. What's up, Willa? Kind of. Why? What's up?
We have a cello downstairs, but like it's difficult to tune because the pegs. Do you know how to tune a cello?
No.
Okay.
No.
It's okay.
I'd imagine that it's tuning like I know how to tune a violin, but I don't know how to tune a cello.
Like the pegs won't stay; they just go back to where they used to.
Oh,
and I keep
that
trying
just
to
means
turn
you've got bad pegs. Yeah. There's nothing I could do about that. I could tune the cello,
but
if
it would
if
still.
it still slips, then you know
Then we get a
you
new
just
cello.
call me down in 5 minutes and
So we
tune
have
it
to get a
again.
new cello.
No, you probably just have to put grease on the pegs, or like tighten the pegs, or something
Okay.
like that.
Alright. Sorry for interrupting.
No worries. All right.
Thanks.
This graph kind of looks similar to the exponential, but it's not exactly the exponential. I would argue that this must be the graph for the logarithmic, right? Because the first two options were definitely exponential.
But like those two look really similar.
Yeah. So how do you tell the difference? I love our thought process here. Do you guys get what I'm saying? Mr. Dalday didn't have time to teach you logarithms. And now you have a question on logarithms, and how the heck am I going to answer it? Well, I can definitely say, first, that of the 4 options, 2 of them were exponential. I'm going to cross those out. These are the 2 that are left. Those must be the logarithmics. Okay? The way you tell the difference between the 2 is this thing right here, and I think Bradley figured it out. The +4. What does that kind of look like to you? Or what does that remind you of? Bradley's suggesting that it moves it to the left 4 units.
Okay.
Right? Right? Because remember that H moves it right and left? but it does kind of the opposite of what we usually think it does.
Mhm.
Do you remember this was back in quarter 2, which you've got an A in,
Yeah.
so you should remember this stuff.
I'm sorry too.
Yeah. See that plus 4? It kind of moves it to the left 4.
Yeah.
So which of these graphs would you say must have been the graph that was moved to the left 4? This one?
So it moves in
And
the
this,
opposite direction.
my friend, is the correct answer. And yes, when you're moving
Okay.
horizontally, it moves it in the opposite direction of what you would expect it to move. So without knowing anything about logarithms, we were able to answer that question. Only using our knowledge of transforming graphs. I think that's powerful. Amazing. I don't know. To me, it makes me excited. What do you think, Bradley? Bradley's like, okay, I can get it.
Just hopefully people watch it so we don't fail this question.
Yeah, hopefully you listen to Kayla, hopefully you watch my videos, so that way you guys don't fail the questions. I almost want to skip to another one and cover a topic just like this. But you know what? I can't find one right off the bat, so I'm going to just stop this archive, and then we'll move on to the next thing. All right, cool.